Boa noite, pessoal. Bem-vindos a mais um Bear Talk. Hoje a gente tem o prazer de se reunir com a Cathy Faux, a treinadora Maple Bear, que está com a gente aqui na escola, e ela vai falar um pouquinho para nós sobre a matemática na Maple Bear. Thanks, Cathy, for being here with us. It is a pleasure. We're happy to hear you uh, and hear all your experience and how Maple Bear works with mathematics with the children in our program and how it works so well.
Excellent. Thank you so much for having me join your school community, and being able to present to the parents is a real privilege. Thank you.
Thank you. Well, I could introduce Cathy, but she's gonna do it herself because it's better. She knows
Okay.
herself better than I do know her. So I'm just gonna leave Cathy with you. And
Excellent. Thank you. Hello, hola. My name is Cathy Faux, and I am a Maple Bear trainer from Canada. I have over 30 years experience with the Canadian school system. Just a little bit about myself before we begin. I live in the Ottawa area in Canada with my husband. I am blessed to have two grown sons, one who is married and has a son of their own. And I'm just so thrilled that you have joined us for this math presentation. Thank you. Let's get started. So here's the outline for the presentation tonight. As you're watching it, we're going to examine on how children learn mathematics at Maple Bear, what's happening in the child's brain during an interactive math lesson, how children develop a math mindset, what you can do to help at home, and resources that will be beneficial for you to use while you're at home with your child. The Maple Bear philosophy includes the following: to foster conceptual learning, where students think and they understand the mathematical processes. We want students to develop and feel positive and confident about their learning. And we want to create classes that have a very stimulating environment. Now, do you remember what your classroom looked like as you were growing up? We have two pictures here. Which one looked like your classroom? The picture on the right is what we call a student-centered approach classroom, and that is the Maple Bear way. When we look at a student-centered classroom, we think about teaching the big concepts. We think about utilizing manipulatives and a variety of other resources to teach the students. We want them working in groups, cooperating and building on their learning with each other. And we want students to have authentic learning experiences. And that's what we call a student-centered approach. Learning is when you learn something by memorizing a rule and applying it to get an answer. Conceptual learning is when you are shown a concrete way to find an answer, usually by using manipulatives or pictures, and that enables a deeper understanding of the concept. And this is the way we want to teach your child. We call this discovery learning. The emphasis is not on teaching, but it's more learning through trial and error, manipulations, concrete learning, and coming up with answers. So, what's happening in a young child's brain? Well, we know the brain is like a sponge at this age when they're young. Children have more time to learn. There's fewer inhibitions at this point. Children have a brain designed for language learning. We know children learn as they explore, and we know children's brains are constantly active. Jo Boaler is a mathematics professor at Stanford University, and she's been studying brain research. Her research indicates that with the right teaching, we can ensure that students are confident learners in mathematics and feel positive about math. Embedded in this slide is a link to her TED Talk where she explains the research. And I invite you, when you have an opportunity, click on the link and just listen to Jo Boaler. You can get it in the Portuguese closed captioning as well. It's about a 15-minute video, and it's very worthwhile research to listen to. So what is a math mindset? Well, when you believe in yourself, your brain works differently. This is known as a growth mindset. You're willing to make mistakes and learn from those mistakes. And we know when mistakes happen and you learn from it, your brain grows. Struggles and challenges are good for you. It's not important to be fast in math. It's more important to think deeply and creatively in terms of how can I solve this problem in many different ways. Math is more than memorization and numbers. We know that math literacy involves thinking and talking about math concepts, children working in groups, sharing their thinking with the other students to develop a broader and deeper understanding. We know children love to explore. We want them to connect, we want them to practice, and we want them to think and reflect about ways that they can use the manipulatives to solve their problems. When you put that all together, we know that children are learning to analyze, synthesize, compare, contrast. They question what they're doing. They're observing the other children. They're bringing the ideas together and consolidating that, and they're communicating their thinking. They're sharing their thinking with others. Math is truly everywhere in our lives. Think about all the times you observed math today since you woke up. At home, at the office, maybe at the grocery store. We know math is everywhere in our daily lives. Math is in the world all around us. In this picture, what do you see? A variety of different math concepts, certainly. Do you remember learning math at school? It was often just memorization without any real deep understanding of the concept, like what did it actually mean? We want students to develop a conceptual understanding of how to think about deeply the mathematical procedures and the ideas. We want to ensure that procedural fluency is also utilized in their math. So when you think about math, you look at the different ways students can solve the multiplication strategies. There's 3 different ways to actually think about 3 times 4 equals 12. Dividing into groups, knowing as repeated addition, and using arrays as a way to solve that one question, 3 times 4. When we think of a student-centered approach, we think of Confucius saying, I hear and I forget. I see, I remember. I do and I understand. Knowing that hands-on learning is the deepest approach. With hands-on learning, we know manipulatives using counters are very important. It allows the students to demonstrate their learning in many ways. Manipulatives help students learn by allowing them to move from a concrete experience to more abstract reasoning as they deepen their understanding in those math concepts. The importance of manipulatives helps the students connect and represent their learning at that deeper level. Manipulatives provides hands-on learning that activates parts of the brain that support understanding. Let's take a look at this school video of a student here in grade 1 using manipulatives to solve the problem 5 plus 3.
4, 5, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8.
She did a marvelous job representing 5 plus 3 in the equation for the sum of 8. She was able to pull apart the values and bring them together to solve that particular problem. Through the use of manipulatives, students can observe and understand the concept of constancy of number. The number operation that we see in this slide of operation is being used here using different numbers being added together to give the same sum of 5. This becomes important in understanding what we call the base 10 system, which we'll look at next. In the base 10 system, each number is composed of digits. For example, in the number 136, 1, 3, and 6 are each digits. When they're combined in a certain pattern, they mean the number 136. And if you look at the picture representation on this slide, you can see in the red, we have 100 cubes, squares, or unifix cubes, as the students like to call them. And then in the orange, we can see that they're in columns of 10. So they know to count 10, 20, 30. And then the yellow indicate the single units. And combined together, we do get the number 136. Our world is filled with patterns and creating patterns. Again, the use of manipulatives allows students to play with patterns and create new patterns. And that's an extension of what they can begin to do in deeper understanding of mathematics when they're playing with patterns. Another area that we want to develop for students is the idea of supertizing. This is the ability to instantly recognize the number of objects without actually counting them. Much like the importance of being able to calculate estimates, supertizing is something that comes up in everyday lives of students. If you take a look at the slide pictures, you can see the first picture shows students using a die and they're rolling it. And to be able to look at the dots and instantly know that it's 6 without counting one by one is a progression in the continuum of math learning. So we work with students as they get developing to be able to quickly identify numbers to supertize together. And on the right-hand side, you can see different ways we supertize. Often when we put up our fingers like this, you and I know it's 4. But for the young ones that are still developing, they'll count the fingers still. And then those students that can automatically recognize this is 4, they know then when we add that together, it becomes 7. They're supertizing. In school, the students participate in daily calendar activities. This reinforces many math concepts that is done in a fun way. There's one-to-one number correspondence. There's before and after. There are skip counting. And you can see the patterning in the particular calendar in this slide has the color pattern. And you can see that they have what we call an ABC pattern. So blue, red, green, blue, red, green. And if we were to hide the next number of 8, we would ask the students, what's your prediction in that pattern? We want them to be able to see those patterns all around them in the world as well. Using the classroom manipulatives, younger students can demonstrate that their one-to-one correspondence counting, and that's when they touch each object and count at the same time. We want to foster a joy of learning at home. It really is the most important gift that you can give your child. Encouraging and supporting a child's natural curiosity sets a lifelong foundation for learning. And we want you to foster that joy of math at home as well. At home, there's easy manipulatives that you can find just in the cupboard that are at your home. There's paper and scissors. You can find rocks. You go out for a nice walk around the neighborhood and pick up some rocks. Pasta, the bow type pasta is the fun pasta to be using. You could use cans. Dried beans, excellent manipulative. Coins, clocks, you can look at the time on both digital and analog clocks. Playing cards are wonderful. They're a great way to develop math skills at home. Dice games, and Lego building patterns and looking at spatial awareness, very important for children at home. Which one doesn't belong? This is a great way to think about various concepts and attributes and implement that math literacy. In this activity, there's no answers provided because there's many different ways that you could look at which one doesn't belong. So let's take a look at the playing cards. You could justify and say, you know what, the 5 may not belong because the card is actually a black colored card versus a red color. The 10 may not belong because it's an even number and the other numbers are odd. The 7 may not belong because if you double the 5, it equals 10. If you double the 3 below it, it equals 6. So maybe the 7 doesn't belong. Oh, maybe the 10 doesn't belong because it's a double digit. The 5, the 3, and the 7, they're all single digits. So as you can see, there's no right answer, but there's a way to justify the answer you've selected. And this is a great way to get discussing different math concepts. You can make a which one doesn't belong out of food items, and you can see that there is a donut and a coffee. There's shapes that belong to that. There's colors, there's 3D elements, lots of mathematical language, just implementing which one doesn't belong. And it can be done so quickly at home as just a fun activity while you're cooking dinner or making lunches and all those fun activities that you do at home together. Highly, highly recommend you do this with your child. It enables you to get into a deeper thinking about how your child is seeing math in their world. So let's take a look at this visual storytelling estimate game. So in total, we have 42 balls. And so we want children to look, okay, totaling 42. What makes sense? It's a really great question to ask your child. Does that make sense? So if we look at the first container of balls, how many are in there, do you think, if you had to estimate? Okay, now let's look at the second one. You know, if I had to think about it, it looks like there are less balls in the second one. So I would estimate a number less than 11. So now we know there are 42 balls in total. We've been given the information that we've just revealed. 11 plus 9 is 20. Therefore, how many balls should be in the third container? You guessed it. This is a fun activity to use. It really, again, gets into the insight of how your children are estimating. Because if a child estimated the first container had 45 balls or even 100 balls in it, then it gives you an idea, okay, we actually have to pull out the balls and we have to count those balls so that the child gets a better understanding of a better judgment of estimation. How can you help at home? Look for those teachable moments. Math is everywhere at home. The challenge is to find those teachable moments. Make sure you don't force it though. We're going to do math now. Make it fun. Be encouraging. Do it in the sly so that you're sneaking in those math moments and the students' children don't even realize it. Talk about shopping and talk about, today I bought these 3 apples and each apple, they cost $5. Each apple, $5. Let's get some macaroni out and let's find out how much it was in total. Teach them about budgeting. Let them teach you. They bring home some math. Say, oh, can you tell me about your math? Can you teach me, please? Ask questions about what they're doing in math and ask them how they solved that problem. Best part is to play games, card games, guessing games, chess, dice games. They're all filled with rich math experiences that are fun. And don't forget, ask your child to explain their thinking. I provided a few samples of some of the games you might want to choose. The card games in the middle, there's a link that you can click on, and it has a selection of a variety of different home games for different age levels too, that you can play with your children, just to give you some ideas. And these particular card games do have a slant towards math development, of course, because they're number games. Make sure you have fun, you have a positive attitude, and play and learn along with your child. I've included some resources here that are used for this slide presentation and that you could actually go to and explore on your own as well. Obrigada. Thank you very much for joining us for this math presentation. It was such a privilege.
Cathy, thank you so much for telling us how we work at Maple Bear, and also how parents and families can help their children learn math better. Well, I have a few questions. We always have some questions from parents. We picked 3 of them. I believe you might have answered some of it already.
Okay.
But if you don't mind asking, if I ask you again.
No, not at all.
So the first question that came to us is, what are some good math questions to ask at home?
That's a really good question. When your child has brought home some math work and they are working through it, it's a really great idea just to say, how did you figure that out? And have them use that math language so that they can explain their thinking to you at home. And you'd be surprised at the way that they have solved it. May not have been the way that you would have solved that math problem, but it's a really good idea to get inside the thinking of how that child has solved that math problem. You could ask them, in that particular math problem or that activity we're doing here at home, do you see a pattern? What's the pattern that you see here? And have the child again talking about patterns that they see at home. If you've identified a particular shape or they're working on a particular shape at school, Perhaps they're working on circles or triangles or rectangles or whatever. You could do a walk through the bedrooms and the living room. Where do you see rectangles in this room? And have them, because that's authentic, that's their life. And so have them look with a different lens around the house, because you want to let them know that math is all around them. It's not just at school, working with the children during the learning centers. It's everywhere, and we have to look at the world with a math lens.
Thank you for that. And that's how it works at Maple Baron Canadian Education. It always amazes me how we look to the process and how to do it instead of just giving them an answer.
Exactly.
So understanding how they think and how they like to think, right?
Exactly. Yeah.
It is definitely something really important. And the second question is, how can I help my child learn to like math? So if my child doesn't like math that much, doesn't think it's something for him or her, what should I do?
Good question. First of all, I'm going to ask the parents to make sure that they have a positive attitude towards math. And I say that because sometimes at school, when we were younger in math class, we may have had a difficult time, but we've had those special teachers that have brought out a joy of working with numbers. And so we have to remember that our attitude towards math can be picked up by our children. And they know if we're timid around math, they themselves might be timid. So I want you to put on a happy face, and I want you to show a joy of math to your child, so that they look at you and they go, oh, you enjoy math? Well, I'm going to give it a try. So that's a starting point. Making math fun at home and not a chore to memorize multiplication tables and all those sorts of things, but making it fun will be really important to have a positive attitude. But it starts with the parents.
That makes sense. I have a 6, almost 7-year-old son, and we always play with numbers.
Perfect.
And I tell him that mathematics, it's all about summing and subtracting. That's all it is. Even when you come to any other, let's say, more difficult equation or something that comes up, it's all about summing and subtracting. So it's easy to do.
Yeah.
Once
And we want them to have that deep understanding of that. You're right.
Yeah. And the third question,
Okay.
Is it better to show children how to do math or let them figure it out for themselves?
That's a very good question. Students and children learn more deeply through mistakes. And that's what the research shows in that slide. So I would invite the parents to take a look at that presentation by Jo Bowler. She is an amazing research into mathematics. And she has found out when we make mistakes, and I think this is for everybody, when we make a mistake and reflect on that mistake, and we go, oh, that didn't work, and we figure it out in a different way, we make deeper connections to that learning. So it's really important to allow the children to make mistakes. If you see a child making mistakes, ask them to explain how they came to that answer. Oftentimes what happens is they recognize, they went, oh, I made a mistake, and they'll self-correct themselves. If you ask them to recount the groupings of the manipulatives, they'll recount and they'll go, oh, that was a mistake. If they actually come up with the same incorrect answer, it gives you an insight as to why they're making that mistake. And if they're making a mistake, that's when you can gently guide them and say, when you were counting, you missed the number 9. Let's take a look. So we can't skip number 9. We have to include it in the counting. So allow them to make the mistake. if they make the mistake, ask them again to explain themselves. They may self-correct at that point, or they may make that mistake, and that's when you can help them and guide them. But please don't give answers. As tempting as it is to give answers, they won't learn as deeply from that.
That makes sense. And that's the process for learning. Sometimes we have to make mistakes to understand why we made those mistakes.
Absolutely.
Not
Still
make
at
again.
my age, I'm making mistakes and I'm learning from them.
You're young. You're young. We
Oh.
are all making mistakes and
That's
learning
right.
from it. And
That's right.
good. If we learn from it, that's how we grow.
That's right.
Cathy, thank you so much for your time. Thanks for coming all the way from Canada to join us in person and also virtually here for this Bear Talk. And we hope to have you again at some point.
Oh,
Once you leave, we're already missing you.
it's been a privilege and pleasure to work with the children at this school. Moms and dads out there, you have lovely children, and it's been such a delight working with them. Thank you.
Thanks, everyone. Pessoal, obrigado. Espero que vocês tenham gostado da apresentação, aprender um pouquinho mais como que a gente trabalha com matemática nas escolas e que a gente consiga, a gente se trabalhe para continuar ajudando as crianças a se desenvolverem e se tornarem, né? Se tornarem o que a gente quer que elas se tornem, tá bom? Um abraço para todo mundo. Obrigado. Tchau, tchau.